y, axis of y here, axis of x in both the cases. This kind of figure of curve tracing is of this kind. Okay, so this is curve tracing here. What we did, we found out the points at what points the in the range at which the curve is not defined. Okay, so that range was x equal to a plus minus a and y equal to plus minus a. And away from that, the asymptotes were possible. Okay, so that was the curve tracing here. Now let me take next question. Now second question, what is second question here? Question number second is, okay, here trace the curve xq y minus x minus 1. Now this curve is not passing through the origin. Okay, because here constant term is here, this minus 1 is there, no even term, so this is not symmetric to any any curve here or for any axis, not symmetric curve. This is not symmetric curve here. Take first axis, so symmetry, no symmetric. It is non-symmetric. It is not a symmetric curve. Why? Because though no even power of any variable, it is x cube here, y is single, x is single. Okay, this is non-symmetric here. Now second point, let me talk about how to. Okay, if I equate the smallest term here, smallest degree term of this equation to 0, if I find out the tangents here, x equal to 0. So x equal to 0 is a possible tangent here. Okay, so if I find the point at which the curve is crossing the tangent line, so that let me find out. So x minus 1 equal to 0, sorry, this, if I put y equal to 0, okay, then x equal to 1, x equal to minus 1, sorry. So at y equal to 0, if I put, if the curve is cutting the any axis or not, so y equal to 0, if I put here, this x equal to, imply that x equal to minus 1. So curve will, let me draw simultaneously also. If the curve is cutting at this point, minus 1 and 0. X is minus 1 here and y 0. At this point, curve is crossing the figure here. Okay, and when x tend to, let me find out value of y here, and y is equal to, that means minus is plus 1, x plus 1 or 1 plus x, this is 1 plus x upon x cube. 1 plus x upon x cube. For negative values of x here, y is negative, y is not defined. Okay, so what is that range? If I take x cube or x is negative value, for negative values of x, y is not defined here, but y is not defined here. So what the figure? If x is negative, and if I take this curve will cut here like this. But for this, the curve is not defined, negative value of x. This is one of the curve here, because at minus 1 it is cutting, the curve is crossing, but x equal to negative values, for negative values of x, value of x or x cube is if negative. Okay, x is negative, then x cube will be negative. So for negative values of x, y is not defined or is imaginary. Y is not defined or is negative. Y is negative. So y will be negative in this case. That means, or if x tends to 0, y tends to infinity in this case. X tends to 0. Whenever x tends to 0, y tends to infinity. So at x tends to 0, y tends to infinity. It means that x tends to 0. When we put x equal to 0, it is infinity. It is infinite here. Similarly, from this side also, you will take a, or we can take like this for x equal to, let me take some other points here. What kind of figure it will be? Change the marker. This is not possible. Okay, so this is -1 and this 0. Now, another point, if I define this point, that figure, one second point is that for x equal to a different value of y, x tend to 0, for x tend to 0, y tends to infinity. This figure is also not possible. So because here we find that y is for x tend to 0, y tends to infinity. Y tends to infinity. This is the figure here. Y tends to infinity for x equal to. This is asymptote upon the positive direction of y also, or negative 0 also, or when x tends to negative infinity, or let me take 0, then y tends to infinity in both the cases. Okay, for 0, x tends to 0, y tends to infinity. Or similarly, if I take x, value of x, if I solve, and taking x common, okay, so if I take x common here, it will be 1 upon y, okay, or if I on x here, that will be 1, y can be calculated if, sorry, only y can be calculated. There the figure here, this is x-axis, y-axis, y dash axis, origin. Okay. Now in this case, what we have to know about it, that whatever the values of x are there, if I solve this equation for x equal to 0, if I put y is not defined. Here x 0, y is not defined because this is 0, this is 0. Completely y is not defined. For x equal to 0, y is not defined, that means y is infinity. For x equal to 0, y is not defined or is infinity. Y is not defined. That's why I've taken this. Y is not defined, or y tends to infinity. So at x equal to 0, y tends to infinity. Okay, and at y tends to, this is y tends to 0, x tends to infinity also. By x tends to infinity, if I take y here, and x q is there, y tends to 0, okay, x tends to infinity also, x tends to infinity at y equal to 0. This is what you call asymptote. So these two asymptotes, but this asymptote, because within this space, this area, there is no curve here. Curve is not passing through the origin because constant term is there. These kind of two curves are there. This is the curve tracing of question number 2. X cube y minus x minus 1. So we find out some points here because only this cutting point is there of the curve. The curve is crossing the axis of x dash, x axis at point -1 and 0, as we have calculated from this, x equal to -1. If y is 0, if y is 0, this term is 0, x equal to -1. So x equal to -1, y equal to 0. This is what y 0 and -1, this curve is cutting, crossing the axis of x at point -1 and 0. But at asymptote, when x tends to 0, y tends to infinity. This is the asymptote which is reaching up to the infinity. So this is the figure of question number, curve tracing of question number 2. Question number 2 is done. Let me now talk about question number 3 here. What are the other points here? Question number 3. So for curve tracing, we have to find out the crossing points at what point the curve is crossing the line, the axis, that axis points. Now question number 3, let me talk about it. Now here y equal to x cube. Here y equal to x cube. So this is cubical parabola. Question number 3 here, y equal to x cube. This is known as cubical parabola. cubical parabola. Okay, so what we see here, at y equal to 0, x equal to 0, because this is passing through the origin. So this curve is passing through the origin, symmetric. Whether it is symmetric or not, because no even power, so curve is not symmetric. X-axis, x-axis, origin, y and y-axis. But before crossing this, let me find out some points here. So at x equal to 0, y is 0, because this curve is crossing through the origin, passing through the origin. First point, solution here. The curve is not symmetric. Let me talk about the curve is not symmetric. First point we always talk about. First point. Second point, the curve is passing through the origin. Curve is passing through the origin. Passing through the origin. Okay, so 0, 0 point is there. This is included 0, 0. Curve is passing through the. Now let me find out some points. If I put x equal to 1, y equal to 1. So x equal to 1, if I take y is also 1. Let me take, this is 1 point, this is 1 point. 1, also 1, this is minus 1, and y is minus 1 here. If I put x equal to minus 1, y is also minus 1. So this point will be minus 1 here. It means the curve is like this. Curve is going like this. This is passing through like this, because this is point here, at point this. There also the point is, one point is this. If I take 2 positive, then x is 2, but y is 8. It will be 8 here. Okay, so in this way the curve will be there. Curve tracing, find out some points here. X equal to 1, no asymptotes here, because at x equal to 0, y equal to 0. This passing to the origin. Whenever the curve is passing to the origin, that means there is no asymptotes here. Okay, so in this case, no asymptotes. Third point, no asymptotes. No asymptotes. Okay, so curve is passing through the origin that we have discussed. Curve is passing through the origin, 0, 0. And these are the points. We just find out some points here. X equal to 1, y equal to 1. Okay, this is the point here. Passing through. But at x equal to 2, y is 8 here. Suppose 8 is here. In this way, the curve is there. And at minus 2, y will be minus 8. This is here. Minus 8, y equal to minus. X equal to minus 2, y is minus 8 here. This kind of curve we will find out. Okay, so this is the curve tracing of question number 3. We find some points and draw the curve here. This is curve tracing simply. Asymptotes are not there, and no symmetric curve. Curve is not symmetric to any axis. Now let me take question number. So this is curve tracing of question number 3. Now let me take 4th question. What is question number 4 say? Is it passing to the origin or not passing to the origin? Question number 4th. Question number 4th is y equal to x cube minus 3ax square. Okay, so no constant term. Curve is passing to the origin. Okay, the first solution we are finding out. First is curve is passing through the origin. Passing through the origin. No symmetric curve. Is passing through the origin. Why origin? Because if I put x equal to 0, y is also 0. So 0, 0 point is included here, passing through the origin. Second point, it is not symmetric curve. It is not a symmetric. It is non-symmetric curve. Why? Because no even powers are there of all the curve, because x is having even, but xq is also there. Y is not even, so it is not a symmetric curve. Second point. And third point, if I solve it, if I take x square common, then y is equal to, okay, so y is here is equal to x square. If I take common, it is x minus 3a. So this point, if I put x equal to 0, y equal to minus 3a, there is a point x equal to 0, it is 0, y is 0, that we have done. But if y equal to 0, then x equal to 3a. It is crossing the y equal to 0, crossing the x-axis at 0 and s 3a and 0. Okay, so going through at x equal to y at 3a, we may say at x equal to 3a, y equal to 0. It means curve passing through the origin, as well as at the point this, again it meets the curve, meets the axis of x at the point 3a and 0. Okay. Let me draw the curve here. Origin, it is passing through. Another point is, suppose this is a, 2a, and this is 3a. This is the point here. Okay, and if I take some other points, if I take x equal to here, put x equal to 2a, or if I put x equal to any other point, suppose a is here, it will be a square, it is a minus a 2a, y equal to minus 2a square. Okay, or y equal to minus 2a. That can be there. X equal to, at x equal to a, if I put x equal to a here, y is equal to what? Minus 2a and to a square, that minus 2a cube. That point is there. It means this point is, and at this point we have to meet here. Curve like this is there. The another point here. Curve is passing through like this, and then at other points, so at x equal to a, let me take x equal to a. At x equal to a here, this is x equal to a, x equal to 2a. Here the point is 0 and 2a, 3a and 0. Y is 0 here at x equal to 3. This is the point included, because this is x-axis here. Y-axis, y dash axis, origin, x dash axis. Now at x equal to a, if I substitute, then y will be equal to a square into minus 2a. It will be minus 2a cube. It will be minus 2a cube, y is equal to minus 2a cube. Let me take here a, this is minus 2a. At this point, but x equal to a, then I have to take here. So we have taken the curve, something different. With at x equal to a, y equal to 2a. At this point, this is a and minus 2a cube. So this is minus 2a cube, all right. That can be a different value, no problem. So at this point, we are taking this point here. So if I find out tangent here, y equal to 0. So y equal to 0 means this is the line here, which is axis of x. We have to take a parallel axis of x to this point at which y equal to 0, at x equal to 2a. Sorry, at x equal to, here y equal to 0, this is x-axis which is parallel to the axis of x. under x-axis we have taken here at this point minus 2aq, x equal to minus 2aq, at x equal to a, we have taken this point. This is the curve, shape of the curve which is passing through this point here. So 2a and minus, sorry, x equal to 2a, if I put x equal to 2a here, then if I take x equal to 2a, then it will be, I think, negative. It is 2a here, then figure will be like this. I'm sorry, it is not x equal to a, but let me take x equal to minus 2a. If I put x equal to minus 2a, it will be minus a at x equal to minus 2a, or only x equal to 2a, sorry, it will be minus a, 2a, it means, and y will be minus a, 2a minus 3a means minus a into 4a square, that means minus 4a cube. This value will be there, minus 4a cube. Here I have to take this point, this then qa, and take this qa meets here. At this point, at x equal to 2a, this is the point 2a and minus 4a cube. This is the point here in below. Okay, so and then one curve is this, and then this curve is passing through like this also. So that will also go there, and then this is going ahead of this point. This is the curve here which is passing through the origin. Okay, so let me take this point here. So this is the curve 3a0 and 2n minus 4a2. Okay, so this is what we take some points, non-symmetric type curve, because it's not symmetric to both the figure, it is not symmetric, but it's meeting the origin, and at a point this 3a, and at x equal to 2a, this curve comes out to be this value. And even at x equal to a, we can find out here there is a point here which can be a and minus 2a cubed by there. It is minus a, sorry, it is a, x equal to a, and it is minus minus a into minus 2a cube. It is minus 2a cube. This point is also there. Similarly, here also we can find out by x equal to put some other value, 2 upon 3 or something, okay, or half of this value. That is how we can find out the point. So, lot of points can be calculated, but only the middle point here. At this point, there is a line which is touching this point, middle point here. The axis which is parallel to the axis of x here, we have taken this point here in this case. Okay, 2a and this. This is the figure, curve of question number 4 here. Okay, now second case is trace the curve which is semi-cubical parabola. Fifth question, semi-cubical parabola. So in this case, we see that y square is even, or y is of even power. So curve will be symmetric to axis of x. So let me take now question number 5 here. What is the question number 5? Let me talk about. Question number 5 here. What does it say? Now question number 5. We are given here y square equal to x cube. This is question number 5. And let me find out the solution. Now here, symmetric. So it is symmetric first. First point is, it is a symmetric curve. How symmetric? As y is even power, y is of even power. So curve will be symmetric to axis of x. So curve will be symmetric to axis of x. Okay, so axis of x, whatever even power is there, that curve will be symmetric to the axis of x in this case. Second point, passing through the origin also, because the constant term passing through the origin, okay, so 0 point is included. Alright, then it is the passing through the origin. The other possibilities, at x equal to 0, y equal to 0, no problem at all. So passing through the origin also symmetric to axis of x. Some points can be calculated. Suppose x equal to 1, y equal to 1. This is passing through 1, 1 also. So the point is passing through 1, 1. So it is at this, okay, so if I equate to smallest power of the term, if the smallest degree term, is equal to 0, that means y is equal to 0. So y equal to 0 and y equal to 0, there are two tangents here. Double point is possible. So two tangents which are coincidental, two coincidental tangents are possible. Cusp will be there. Two coincident tangents are there. Origin is a double point. So origin is a double point here. Origin is a double point which is a cusp in this case, because coincident tangents are there. Origin is a double point, and that double point is cusp, and double point, and it is a cusp, and it is a cusp here. What the figure then? Let me find out the figure then. What the curve of this? Take curve tracing here. If I trace the curve, okay, it is passing through the origin, and this is the curve like this, symmetric to axis of x. The origin by because y is even here, so this is x dash axis, symmetric to axis of x. The curve is symmetric to axis of x, and this is a cusp here, beak-like cusp. Okay, this is a beak-like cusp. Sorry, not beak but horn-like cusp. It is a keratoid cusp. It is a keratoid cusp. It is a keratoid cusp. This we have defined in the previous lecture series. So, one of the previous lecture series, keratoid cusp here. It is a cusp type of parabola, because here we see that equating y square equal to 0. Y is the smallest degree term. Will be equate the y square to 0, that means y equal to 0 and y equal to 0. Two coincident tangents are possible. It means the origin is a double point here, which is cusp, which is forming a cusp. This is a cusp, first species of cusp. Okay, so this first species of cusp we have just defined here. This is a figure. Question number 5 we have taken. Now let me talk about 6th question. What is question number 6 say? Now question number 6. It says, this is the 7th one. 6 says, trace the curve x square minus a square into y square minus b square equal to a square b square. Question number 6 here. Now in this case, what we see, that when x equal to a, it is not possible. So this is asymptote is possible. Okay. 6th question. It is x square. It is x square minus a square into y square minus b square equal to a square into b square. So it is symmetric. Both the curves, both the axes, because x square and y square both are in even terms here. So solution here. Here the curve is symmetric. First point, the curve is symmetric to both the axes. It is symmetric to both the axes. Is symmetric to both the axes. Second point. So if I define it, or if I find out x square, so at x equal to a, okay, so it is, if I solve it, then x square into y square, okay, that kind of situation will be there. So let me define it as x square, okay, or we can take that, okay, let me define it, x square y square, multiplying this, x square y square minus x square b square minus a square y square, and minus plus a square b square equal to a square b square. What we see here, a square b square cancel out, a square b square, and from this also a square b square positive will come out left hand side. So these two are cancelled out. So this is the final solution. But y square, if I take common, will be x square minus a square is equal to x square into b square. It is possible here. So y square is equal to, this is x square into b square upon x square minus a square. For x is less than a, if I take y is imaginary, it means x cannot be equal to a, because then y tends to infinity. At x equal to a, y square tends to infinity. X cannot be equal to a, okay, because at that situation it will be asymptote. So x is equal to a here. X equal to plus minus a, but x cannot be equal to plus minus a here. If I equate these powers, okay, this is y square equal to x square.